In the second video of 11.2, we're going to talk about geometric sequence, which is a sequence in which each term is obtained by multiplying the preceding term by constant r. Now, don't be fooled by the multiplying. It also applies to dividing, because remember, you can really divide any number by multiplying by the reciprocal. Now, the constant r we're going to refer to as the common ratio. And remember, in the arithmetic, we refer to it as the common difference. So difference refers to arithmetic, ratio refers to geometric. Just to give you an example of what a sequence would kind of look like of that, we're going to write the first four terms of geometric sequence whose first term is 3 and whose common ratio is -5. So I have the first term, and we're going to do 4. I want to start out with the term of 3. Now, common ratio -5 means I'm going to multiply the last one by -5. So that's going to make our second term -15. And again, it's always based on the last one. I'm not multiplying what term number it is, but the last number that we were given. So I'm going to multiply by -5 here. That's going to give us 75. Multiply again by -5. And that's going to give us -375. So again, not based on multiplying by what term it is, but the preceding number in the term. Just like arithmetic sequence, we're given a general term equation that will make it a little bit easier to find that higher term instead of trying to find every single number preceding it. In this case, we're going to do a sub n equals the first term, or the general term equals the first term times that general ratio or common ratio to the n minus first power. Please make sure you have these two formulas memorized, okay? And you'll have to keep them straight. Which one is arithmetic and which one is geometric? In our second example, we're going to find the sixth term of the geometric sequence whose first term is 2 and whose common ratio is -3. So again, we're going to take a look at that general formula, which is a sub n equals a sub 1 times r to n minus 1 power. Our common ratio is 1/3, and our first term is 2. And we're trying to find that sixth term. So for our sixth term, it's going to be equal to the first term, which is 2, times our ratio, which is 1/3, to the n minus 1, which will be 6 minus 1 power. And then we're going to simplify. So 2 times 1/3 to the 5th. And if I simplify that, that's going to be 2 times 1 over 243. And we'll simplify that to 2, or just put those together. 2 over 243. That can't be simplified. Obviously, you'd always look to see if it can. But this would be the sixth term of that sequence. Just like in the previous video, we're going to sometimes get information that's lacking, and we're going to kind of have to figure that out by ourselves. So what we're going to do is we're going to try to find the sixth term of the geometric sequence whose first three terms are -2, 8, -32. We know that our first term is -2, which is help, but we don't know that common ratio. To get to -2 to 8, you have to multiply by -4. And luckily enough, getting from 8 to -32, you also multiply by -4. So our common ratio is going to be -4. So we're going to go back to that formula we have, and we're going to plug in. We're looking for the sixth term, multiplied by the first term, common ratio raised to the term -1. And we're just going to simplify. And then finally, for our answer, we will get 2048 for the sixth term. Example number 4, again, we're going to have to do a little bit of work to figure out what we need. If the third term of the geometric sequence is 12 and the fourth term is 8, find the first term in the common ratio. The easiest thing is going to be the common ratio, because 4 and 3 are just one term apart. So what we're going to do is we're going to do 8 divided by 12, and that gives us 2/3. And that's going to be your common ratio. So if you think about it, to get from 12 to 8, we multiply by 2/3. I'm taking that leading term, dividing it by the next term. So that will give us our common ratio. To find the first term, then, what we can do is that we can just do a basic substitution into that formula. We know that the third term has a geometric sequence of 12, and we know that it gives us 2/3. So we'll substitute in the third term with 12, and then we'll just solve for the first term. So 12 equals the first term times 2/3 squared. So that's 12 equals first term times 4 over 9. I'll multiply by 9 over 4. And the first term is going to be 27. And we're going to finish off by putting into real world situation. The population of a culture of bacteria is tripling each day. Predict how large the culture will be at the beginning of day 6 if it measures 40 units at the beginning of day 1. So right here, the 40 units at day 1, that's our first term. Our common ratio is the tripling, so R equals 3. And we're trying to figure out day 6. So the sixth term in the sequence will be equal to 40 times the ratio to the 6 minus 1 power. If you plug that in, that will give you 9,720 units.